Today we're going to start chapter 6, finally moving on to a new chapter, and today's lesson is all about the law of signs. So in our warm-ups last week, you saw problems where you had to identify the type of given information, and this is going to be very important when we do our law of sines and law of cosines. We are now moving on from our right triangles, and we have now what's called an oblique triangle, and oblique triangles just don't have that right angle in it. So what I do for these is I draw a picture of the triangle, and then I label the given information. So they gave us angle A, they gave us angle B, and they also gave us little side A, which is across from angle A. If you look at this going around the triangle kind of in a circle, the three things that they give us is an angle and then another angle, and then the next thing that comes along is a side. So this given information is angle, angle, side. For the next one, here's our triangle. They gave us angle B, side A, and side B. And so if you go around in a circle, you see first we have an angle, and then we come to a side, and then we come to a side, and that spells a bad word, and we don't want to write it in that direction, so we're going to go in this direction so we don't have bad words all over our paper. And the last one, we're going to have our oblique triangle, and A and C were given, and side B was given. And this time, if we go around in a circle, the side is between the two angles. So this is angle, side, angle. And depending upon the different types, that'll tell you if you're going to use law of sines or law of cosines. These three, you will always use the law of sines for them. With angle, angle, side, angle, or side, 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 they have to use the law of sines. Here is the theorem that we could use to prove where the law of sines comes from, and it comes from two triangles that are inscribed in a circle. And you can see that one of the triangles is a right triangle. So some of the relationships that that mathematicians drew from was that you had right triangle trigonometry that then led us into how we could come up with a formula to find the sides or the angles of an oblique triangle. Because of time, I'm going to skip this, but I will do another video just of this proof if you're interested on where it came from. This is the law of sines right here. This is what you need to know. And this is what we would have found in that little application on the last side. You could use the sides on top, the lowercase letters are always the sides, and the sign of the angles on the bottom, or sometimes people write it with the angles on top and the sides on the bottom. It really doesn't matter, but what you're doing is you're setting up a proportion of the ratios of the sides of the triangle to the sine of the opposite angle on the triangle. So here's an example, and it even gave us a picture to go along with the given information. The first thing you're always going to want to do is figure out the given information, whether you have the picture or you have to draw a picture yourself. So the way we see this, we see that we have two angles and then a side. So this is angle, angle, side, and as I just talked about, this is certainly going to be the law of sines. This is how I like to organize myself. So we're going to put down 33 degrees for angle A, 105 degrees for angle B, and little side C turns out to be 97.9. Your job is going to be finding all the other missing pieces. So what you're going to do is you're going to set up your law of sines proportion, which is side A over the sine of the angle, side B over the sine of the angle, and side C over the sine of the angle. The very first thing you can find is angle C. So the way we would find angle C, of course, would be taking 180 degrees minus the two angle values that we already know, and that should be 42. Now that we know that piece, we got to fill in other pieces of the puzzle, and it really doesn't matter which way you go. You could work with finding A first, or you could work with finding C first. We're working with a proportion, so you're going to cross multiply. So on your calculator, you're going to multiply 37.9 times the sine of 33. Then you're going to have, maybe I'll show you this, 37.9 times the sine of 33. And then you're going to have that equal to the sine of 105 times A. So we're going to solve for A, so you're going to have to divide this by the sine of 105. So you put that into your calculator, and you get a value for A, and that would equal to be 24.4. Then you're going to go this way and find C. And the way you're going to find C is by taking the sine of 42 times 37.9 and then we would divide by the sine of 105 to get C. You have to be very careful putting this into your calculator, particularly with parentheses, to make sure you get the right answers. So this is 26.3. So I would do these on your calculator and make sure you get the exact same answers that I have here. So with the law of sines, when you are given information of angle, angle, side, or angle, side, angle, it turns out you could get one possible triangle like you just saw in the last example. Sometimes they'll give you given information that doesn't work at all. So you could have 0 solutions too. Not usually with those cases. But the pain in the angle or side angle case is called the ambiguous case for a reason. Because what you have is you have a swinging side that can change the value, and you could come up with 2 triangles. And so whenever you have this case, you need to look for the fact that you could have 2 triangles. All right, so to start this one off, you can see I did not give you a triangle to look at with the given information. So we know angle A, we know little a, and we know little b. So this is a side angle case, and we have to be careful to make sure that we get the right amount of triangles because we could have 0, 1, or 2. So then I like to write down my given information. 105 is given, 73 and 55 is given. So now I'm going to set up my law of sines proportions. So 73 over the sine of 105 equals 55 over the sine of B equals C over the sine of C. There's no way to find another angle right now because we only know one angle. So the only angle we can find right now is B. And the way you're going to do that is by cross multiplying. Whenever you have side angle case, knowing the first angle you found is very important, and I'll show you why in a minute. So we're going to cross multiply. We're going to take 55 times the sine of 105. We're going to set that equal to 73 times the sine of B. To get B by itself, you're going to divide by 73. And then you got to take the inverse sine. And you do that on your calculator. And the inverse sine should turn out to be 46.7 degrees. Again, it's important to remember that's the first angle you found. Star it, box it, whatever. We'll come back to it. All right, so now we know that that's B, 46.7. And we can find angle C by subtracting. This column should always add up to be 180 degrees. And so this is 28.3 degrees. You know it's 180 because the interior angles of a triangle add up to be 180. So now since we know that this is 28.3, you can cross multiply. You can cross multiply with B if you want to, but you found B, that's a rounded answer. I would cross multiply with the A values because those are all given. So when you take the sine of 28.3 times 73 and you divide by the sine of 105, we get for our answer 35.8. All right, that's the first triangle. There is a chance that you could have a second triangle and you have to go look for it. So when you could have a second triangle, I always set up my paper and use the little subscript of 2, meaning that this could be your second triangle. Your given information is not going to change. So this is still 73, this is still 55, angle A is still 105. The only thing that is going to change, well, with the way you're going to figure out you have a second triangle, is you're going to take this first angle that we found, remember I told you that was important, and you're always going to subtract it from 180 degrees. So if you can take 180 minus 46.7, I'll have that written down, 180 minus 46.7, we get 133.3 degrees. Okay, so that's my second angle on this triangle. Already you should be saying, I know that I don't have a second triangle. And the reason is because this column has to add up to be 180 degrees. And it's already more than 180 degrees. So that's how we know that this is not going to have a second triangle. And here's why you have this ambiguous case. You have these 2 set sides here. They're not going to change their distance, but you have this angle C that's swinging, okay? So this angle C could be swinging and swinging this line down here, and we could have like a second triangle in here, and then we could have another triangle there. But in this case, it doesn't work. That side is not going to hit this side over here in 2 different places. All right, here's another triangle. Given information, A, B, C. This is A, this is A, this is C. Again, going this way, it spells a bad word. So it is side, side, angle. Actually, going this way, it spells a bad word. So this is a case that we need to be careful with. We could have two solutions. So this is 30 degrees, this is 8, this is 10. Set up your law of sines. 8 over the sine of 30 equals B over the sine of B equals 10 over the sine of C. Hopefully you see that C has to be the first angle we're going to find. There's nothing else we can do with our proportions but find angle C. Oh, please don't freeze on me. Okay, good. I think I'm back to life, maybe. Oh, please. Okay, there we go. So you're going to do your cross multiplying. You're going to take 10 times the sine of 30. You're going to divide by 8, and you're going to take the inverse sine. When we do that, we get 38.7 degrees. That's the first angle we found. You're going to remember that for our second triangle. Now, we know that this is equal to 38.7. We can find angle B because this column has to add to 118, or 180, I mean. So when you subtract, that gives you 111.3 degrees. So B is 111.3. And now you can cross multiply. I would cross multiply probably with A and find little b, and that's 14.9. Okay, there's a chance we could have a second triangle. So we have to look for that case. And this is 30, this is 8, this is 10. That is not going to change. What does happen is that first angle we found, we have to subtract that from 180. And that's going to give us whatever C2 is. And when you subtract, you get 69.3 degrees. Well, 30 and 69, you should already realize that's only about 100 degrees. So that means you definitely have more left over for a third angle here. And so that difference would be 80.7 degrees. So now you're going to set up your law of sines with what we know. We have 8 over the sine of 30 equals, and all we really got to do is find B2. So you're going to put that over the sine of 80.7, and you're going to cross multiply. And when you cross multiply, this side turns out to be 15.8. Okay, so here's what was happening. Angle C was swinging. This is a set side. This distance is a set side. This angle is swinging. So here it makes a triangle, or if we bring it over here and we have a smaller angle, let's just say this is the same length as A, we have another triangle here. So you can see how in one case, C is much bigger than the other. Even B is much bigger than the other. And then finally, we have our last case. A, B, C. We know B, we know little b, and we know little c. This is another side angle. So B is 118, little b is 8, C is 10. Set up your proportions. A over the sine of A, 8 over the sine of 118, 10 over the sine of C. If you cross multiply, 10 times the sine of 118, divide that by 8, that gives you the sine of C. When you do this bit on your calculator, that gives you 1.103-ish. You're going to try to take the inverse sine of that. And hopefully you know your calculator is going to tell you that you have an error, because this can't be more than 1. Can't take the inverse sine of something higher than 1. So since you get something where it's going to be taking the inverse sine of more than 1, this is a no solution situation. The given information wouldn't make any triangle. These two sides would not hit a third side. It just wouldn't work. So that's the third possibility of the ambiguous case. Okay, you have homework. Now, here's the thing. You don't have packets. So we will post the packets, and in there is the homework. I'll also post the homework separately in a link. You can print it, or you can just look at the screen and do it on regular old paper. But that's how we're going to have to work this from now on, because you don't have any more materials. So that's up to you if you want to print or if you just want to write everything out on a piece of paper. But you need to do that. All right, take care. Have a good day.